Welcome to my video on similar figures. So remember, similar figures means same shape but different size. So our first part here says to identify the corresponding, and corresponding means the matching parts. So one strategy we can do if we know they're similar, and we know rectangle ABCD is similar to rectangle JKLM, then we can line up the letters to see which letters correspond, and it also helps us to see which sides correspond. So go ahead and write down ABCD right about here and line up underneath it JKLM. Now it's very easy to see the ones that are lined up underneath each other are the ones that correspond. So angle A corresponds to angle J. Angle B corresponds to angle K. Angle C corresponds to angle L, and angle D corresponds to angle M. So when you line them up, if you know they're similar, you can easily see which letters correspond to each other. Now the symbol, and it's a little squiggly here, that means similar. So anytime you see that symbol, that means the two figures are similar. So it says AB, and this bar right here means side AB. So side AB corresponds to, so we can either look at the pictures, and since we see the man pushing on this side, we know that AB is the same as JK. Now we can also use the letters that are lined up. AB lines up with JK. Okay, CD, it's on the bottom, so it lines up with LM. And once again, you can look over here, CD lines up with LM. AC, where the man is, lines up with JL. Now look at where we lined up the letters. A is the first, C is the third, J is the first, L is the third, so they line up. Now BD corresponds to KM. Okay, all right angles are congruent and match. The congruent symbol is the similar symbol with an equal sign. Okay, that symbol means congruent. So it says write a ratio of the corresponding parts. So remember, a ratio is a comparison of two numbers. So we know that, and this is the same rectangles as above, but now they have numbers. Okay, it says AB corresponds with JK and BD corresponds with KM. And it says write the ratio of the sides of the large rectangle to the small rectangle. So when we write our ratio, we're going to put the large rectangle on top and the small rectangle value on the bottom. So it says AB corresponds with JK. So just like we did when we did other proportions, we're going to write our unit out here. In this case, it's not a unit, it's a side. So we're going to put side AB on top, and we're going to put side JK on the bottom. So if you look at the picture, AB has a value of 10. And if you look at the smaller rectangle, JK has a value of 5. Now it says ratio, and ratio is a comparison of two numbers. So I know 10 divided by 5 is 2, but that's only one number. So what I'm going to do is simplify top and bottom by dividing by the same number. So what number can go into 10 and 5 evenly? Hopefully you were thinking 5. So 10 divided by 5 is 2, and 5 divided by 5 is 1. Therefore, the ratio is 2 to 1. Now, the other ratio it asks us for is BD corresponds to KM. So if these two figures are in fact similar, then they are going to create the same ratio. So let's see if they do. And we know they're similar, so they should have the same ratio. So side BD corresponds to side KM, so we're going to put BD on top and KM on the bottom, because it said the ratio of the large to the small. So BD has a value of 6, and KM, look at the picture, has a value of 3. Now remember, we're looking for a ratio, so what can we divide top and bottom by? 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. So notice they have the same ratio, and that is due to the fact that the two figures are similar. Okay, turn the page. How can I determine if figures are similar? So we looked at setting up two ratios, okay, like we did before. But now I'm going to show you another way that you can do it, and it's comparing the ratios of corresponding sides. So that's what we did, first figure to second figure. The cross products are equal. So I'm going to show you how to show it using cross products. So we can do side AB. Okay, I know this side corresponds to this side because they're in the same spot. So we can say 6 over 3. And we can say big rectangle over small rectangle. So 6 over 3 equals 10 over 5. So notice I did big rectangle over small rectangle. Those correspond. And I did big rectangle over small rectangle. Those correspond. Now use the cross products. So we can do 6 times 5 is what? 30. And 10 times 3 is 30. So they are both equal. Therefore, when triangles are similar, let's backtrack for a second. Since the cross products are equal, we can say that they are similar. And now when triangles are similar, we write triangle ABC is similar to triangle DEF. So we can either write the words or use this is writing it using the symbol. Okay, now let me show you what you could have also done. Okay, this isn't the only cross products you could have done. Let me show you over here how you could have also done. So you could have done short side over long side. So let's say short over long, and you don't have to write this part down because we already showed one. I just want to see that there's another way of doing it. So the short side is 6, the long side is 10. So then I go to the other rectangle. The short side is 3, the long side is 5. And notice, once again, 6 times 5 is 30. 3 times 10 is 30. So it doesn't matter how I set up my proportion. If they are in fact similar, they will come out to be the same. Okay, now let's move down to the last part of our notes here for today. Are these quadrilaterals similar? So solve by using cross products, then division. Compare ratios of corresponding sides, first figure to second figure or left to right. Now, cross out the part that says then division, because all we're going to do is just solve by using the cross products. So my question is, are the cross products equal? So let's see. 10 times 2 is 20, so we can also write that here on the blank. And 8 times 4 is 32, so we can also write that on the blank. So my question is, are these cross products equal? No, so put an equal sign with a slash through it. So it says that those are not equal, and then write no on the blank here. So if the cross products aren't equal, then are the trapezoids similar? And the answer is no. So this concludes our part 1 notes on similar figures. I hope you have a great day.